Hi, my name is Chloe Nguyen. I'm a data scientist, and today I'm going to talk about opacity detections in chest X-ray. So in the past year, respiratory health has become a major concern to a lot of people, and one of its complications is pneumonia. Pneumonia is defined by the presence of fluids and pus in the small air sacs in your lungs. So one of the most reliable and accessible method of diagnosing pneumonia is chest X-ray. So the goal of my project is to build a convolutional neural network model that takes an image and outputs a probability of pneumonia. So here's some example. As you can see, on the left-hand side, the lungs are very clear, it's transparent, and compared to the heart and the skeleton. Meanwhile, the one on the right-hand side, the lungs with pneumonia have much more hazy and opaque look. So to where the arrow is pointing at, you can see an increase of whiteness that obstruct the lungs marking and the heart water. So I used a data set I got from Kaggle, and that consisted of nearly 6,000 X-ray images. It's come into three different sets. As you can see, I have many pneumonia cases compared to normal cases, which would lead to overfitting issues. So to address this imbalance class, I have to oversample the training and the validation set. So to further address the overfitting issues, I use a method called data augmentations. What it do is stretching and screw and rotate images in multiple different ways. And here's one example where the lungs X-ray is being rotated slightly to the right, and it's also zooming a little bit. So my model works based on a convolutional neural network. As the name suggests, it works kind of like neurons in a human brain. So whenever a feature is found from an image, the neurons associated with that feature would get activated. So the model is able to make its predictions by identifying which of these neurons are being activated by the image. Um, So here's some of the results of my base model, and I use the ROC curve to determine the optimal threshold to plot my confusion matrix. Um, so my base model is better at detecting pneumonia K, like compared to the normal case. Um, and I compare this results with another models using transfer learning from a DenseNet model. And it's doing better with the normal case, but with the pneumonia cases, it's getting worse. So I comparing the recall values between these two models. So in a medical setting, a false positive um, might lead to additional testing for confirmation purposes, but a false negative could lead to a more detrimental impact on the patient, as the doctor can overlook something dangerous or needs more attention later. So here's a visible example of a false positive. So normal chest X-ray like can be very based on the exposure index, the lightning, the brightness. Because of this, it's possible that my model has a very narrow view of what a normal chest X-ray looks like. So that's might be why it gave a false positive in this case. So for future work, I would like to work more on advanced data augmentations where I can modify the brightness values of the image pixel. And this might help with the exposure issues. Um, and I would like also to utilize the class activations mapping to show the area of the image that is most indicative of pneumonia. And here are some of the tech stack that I use for my project. and thank you for listening to me.